Welcome to solverfy.
We have an oxide of nitrogen. This is 40.45% of nitrogen by mass. So what would be the empirical formula? And also if the molar mass is 90% minus 5 gram per mole, what would be the molecular formula? So we first start with part A, what would be the empirical formula? So because we are looking at the mass percentage, we can assume that we have 100 gram of our oxide of nitrogen. So therefore, we will have 30.45 gram of nitrogen. Okay, so we just need to convert that to number of moles first. Um, okay, so okay, before we doing that, we also have oxygen as well, real oxide of nitrogen. So we can also calculate the mass of oxygen should be equal to 100. We will assume 100 gram minus 13.45 grams. So we have 65.55 gram of oxygen. So we convert that to number of moles. For the number of moles of oxygen, it will be 22.17 mole. And then for oxygen, it will be 4.347 mole. All right, so in order to find the formula, we're going to set up the ratio between the number of mole for nitrogen and also the oxygen, and then we're going to simplify it. So we're going to divide the whole everything by the smallest number, 2.173. We should be able to find that the ratio is around 1 to 2, nitrogen to oxygen. So we have NO2 for the empirical formula. Okay, we can move on. Okay, since we know the empirical formula is NO2, and this empirical formula will have a molar mass 14 plus 16 times 2, 46 gram per mole. So we're going to take our total molar mass divided by our empirical formula molar mass. So but you can see that there will be a plus and minus 5 gram. So from here we can separate two such scenarios. So we can have 95, and also we can have 85 because it's 90 the center and 85, 95. We will find out the boundary between the number. Okay, assume we have 95. We are going to have 95 divided by 46. We will find that the multiple is roughly around 2.06. Again, it's roughly around 2. If we were 85 divided by 46, we will have the multiple roughly around 1.45, also roughly around 2. If we take the center number, 90 divided by 46, we also have roughly around 1.96, also around roughly 2. So from the upper boundary and the center molar mass, this is corresponding to 90, this is 95, and this is 85. We can see that the multiple also is roughly around 2. So we can know that the molecular formula should be N2O4 with the multiple by 2. We just multiply that to our